Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking Tableau for sponsoring today's event. Tableau is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Sisense, Click, IBM, DataRobot, Alteryx, and Tibco, to name just a few. Now, past webinars are available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Today's webinar is entitled A Language for Visual Analytics, and that's going to be presented by Tableau. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have one presenter, who I'll introduce in just a minute. There'll be 10 or 15 minutes of Q&A following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon, following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speaker, Jacque Mckinley with Tableau. Jacques has more than 30 years of experience with visual presentation of relational information. Works he has co-written, such as his book, Reading in Information Visualization, Using Vision to Think, have served as key references, foundations for, and catalysts of the field of information visualization. He joined Tableau Software in 2004, and his current work focuses on developing intuitive visual analyses applications for a wide variety of users. So, Jacque, thanks for being with us today. We're looking forward to your presentation. Now, in today's Data Science Central webinar, we'll hear from Jock Mackinlay, Vice President of Research and Design at Tableau, as he describes how he used a linguistic approach inspired by the work of Jacques Bertin to influence the development of visual analysis. Listen to him as he shares the beginnings of his journey in Stanford while studying for his PhD, discusses his current work as the VP of Research and Design at Tableau, and tells us his thoughts about the future of visual analysis. So, Jacque, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you very much, Bill. Delighted to be here and talk to you all. A language is an ancient skill that makes humans a cooperative species. Visual analysis is a modern skill that helps people use computers to see and understand data. It is, in turn, based on another ancient skill, the power of the human visual system. You might be wondering how these two are connected. In this talk, I'm going to tell you a story about how language drove our innovation in visual analysis. I believe everyone can be skilled at visual analysis. The primary reason I'm going to tell you this story is because it will help you be more skilled at visual analysis if you hear about the theory it's based on. And those Tableau users out there will also get to hear how language led directly to some of the features in Tableau Desktop. As you'll see, this is an autobiographical story. It starts with me at Stanford in the early 1980s when I was trying to figure out what I was going to do for my dissertation work. I was walking around the inner quad at Stanford, shown here, and I already knew the problem that I wanted to work on because back in high school, I had read this book, 1984, and yes, that's a picture of me from my high school yearbook, and as you can see, the hairstyles at the time were quite different. Now, 1984 is a book about the use of technology to control and oppress people. And when I read this book, I had decided that technology could also be used to protect us from that technology. And this was precisely the problem that I wanted to work on. Now, by the time I had gotten to Stanford, I understood that visual techniques were going to be very important for that goal. This is a very famous view by William Playfair. He wrote a book that involved economic trade between England, and in this case, this is a line chart about the import and exports with Denmark and Norway. And he also was the inventor of the pie chart. And as you can see, we have very powerful techniques for working with information. And what I wanted to do is give people the ability to use techniques like this, even if they weren't skilled at using them. And so one of my professors at the time was aware of what I was trying to do, which was I was looking for a theoretical foundation in which I could build a computer program to help people use techniques like that. This is Chuck Bigelow. He was, along with his partner, working on digital fonts, so a very graphically oriented individual. He and his partner developed the Lucida fonts. And Chuck came to me one day and he said, he had actually a copy of a book that he said might be useful to me. It was this book here by Jacques Bertin called the Sémiologie Graphique. And I thumbed my way through this book, and I could tell from the pictures that it was likely to be a book that was really useful for me. However, there was a problem, which is that I don't read French. I don't speak French. Now, Chuck thought that there was a German translation of this book, and so I started trying to figure out if I could get my hands on the German translation of the book. A couple of weeks later, however, I was walking through the local bookstore in Stanford, Printers Inc., and I looked into their expensive book cabinet, locked cabinet, and I saw a silver spine. This silver spine, and it said Semiology of Graphics on it. I got quite excited at this point because evidently it looked like that Bertin's book had been translated into English. And so I went over and got the person behind the cash register to unlock the cabinet, and sure enough, it was the book translated into English. And although a very expensive book, and I was a very poor graduate student, I bought it on the spot. And this book became the theoretical foundation that I needed to build software to help people do visual analysis with data. So the first thing I'm going to do is I'm going to show you probably the key technical figure out of the book to explain the basics of this theory for working with data. And so this is the figure, and I'm going to step through it to explain it to you. Across the top are a set of tasks that you need to accomplish if you're going to use visual techniques for working with data. The first task is the association task, which is to say, are particular marks associated together in terms of how they are encoding data? The second task is a selection task. Can you pick out from a visualization the particular marks for a particular data value and use them to select them to be able to compare them against each other? The third is an ordering task. For quantitative or categorical ordered data, can you actually see the ordering of those values? And finally, there's the quantitative task of understanding the quantitative values. Now, that's the columns in this figure. The rows of the figure have to do with graphical properties and whether they can help you accomplish these particular tasks. And so we have, Bertin wrote about 6 of them: size, value, texture, which is to say the textural properties of the marks, color, orientation, and shape. And it turns out that all 6 of these graphical properties can be used for the association task, which is why they're shown in that column. And so you can encode data values with these 6 graphical properties, and people can associate those marks against each other. Now, for selection, the task of picking out particular marks, you essentially have 5.5 that work for them, and I've put a red square around the one that doesn't work. Now, what Bertin was focusing on here was what you could do very quickly with your visual system. You can certainly use shape and select out particular shapes, but you're going to do that slowly. The other 5, however, you can use them to do it very quickly: size, value, texture, color, and part of orientation. And what he's showing with the numbers on this side is the number of different values that you can pick out and select together. And for orientation, it's for 2 or 4 values. But nevertheless, you can use these 5 graphical properties for the selection task. For the ordered task, 3 of them work: size, value, texture, and 3 of them you're too slow at: color, orientation, and texture. And then finally, for size, or for quantity, as the task of understanding quantitative values, size is the only one that works, and the other 5 do not work. So this was the essential information that I needed to build a computer program to help people do visual analysis. And then there was one other figure that actually captures the second half of what I needed, because what I was focusing on was a linguistic approach. And this figure explains essentially sort of the fundamental words of using visuals to encode data values. I also needed the ability ability to put the words together. And that's described in this figure here, where across the top we have the graphical properties I talked about before, the shape, orientation, color, etc. And then on the rows of this is the combination of these techniques. What this particular figure is showing is that you could combine all of those 6 properties together simultaneously to be able to code particular data. And you can see that by the diagonal property here. He's basically working through and showing that all 6 of those can be combined together independently to be able to show those graphical properties. So before I go on and show how I used Bertin's theoretical framework, I want to talk just briefly about Jacques Bertin himself. Many years later, way after I'd finished my dissertation, I got the chance to have lunch with Jacques and his wife, with myself and my wife and a friend who was able to do the translation between French and English for us. And Jacques brought us back to his apartment in Paris. And as we walked in the front door, I saw a map, very much like this one shown here, which is out of another one of Jacques' books, which is a data map with also relief drawing. What was impressive about the map, it was right in the front entry hall, was that it had been hand-drawn. And when I looked at this map, I realized that Jacques was, in fact, also an artist, as well as extremely skilled at doing data analytics. And he had married those 2 techniques together. And the other thing that Jacques had done that was really significant, in addition to the semiology of graphics, was that he had worked on a particular technique for doing analytics with data called permutation matrices. Now that's shown here. On the left column is showing how if you encode data visually and then go through a sorting process, you can then look at how various data values are related to each other. So down at the bottom, you can see that there's a relationship between villages, towns, and cities, and various graphical properties that identify, or various data properties that identify them. Now, this was basically before there were computers, and what Jacques and his colleagues did is they built physical apparatus for doing analytics, visual analytics with data. I believe this is the first really significant use of interactivity for doing visual analytics work. And on the picture on the right, you can see they actually built a very large versions of this technology. And what I have for you is a video of one of the films they shot for doing this work. So let me show you that film. This is a video of that work for you. So the first thing you need to do using permutation matrices is to encode your data visually. And what they used were so here's the data values for some data that you want to be doing analysis with, and they had built these little physical cubes that they could assemble into a visual encoding of the data. The cubes have little holes in them that they will use in a moment to do their sorting efforts. But the first thing they did was assemble those values by hand to combine them. Once the entire table was done, they could insert rods to do in this case to sort, to move one column to another position by opening up the physical table, picking up the particular column that they would want to move, and then dropping it down, and then closing the table back up. Now, they can also, because the holes go bidirectionally, they can also pick up one row and move it to a different position and drop it down, giving them the full power of being able to sort both the rows and columns. Now, in this video, they have a fast forward version, and here you can see them going through a process of sorting all of the columns to try and put particular data values next to each other, essentially trying to diagonalize the matrix. And then they can do the same thing on the row, and then once they have that done, they can then look at the various data properties of them against each other. So that was the first, I think, real use of visual analytics pre-computer time. Now, my next stop on my story is my PhD dissertation out of Stanford titled Automatic Design of Graphical Presentations. Now, here's one of the important figures out of this, which is a little diagram explaining the technology that I was going to create called a presentation tool. And that technology took in some data from an application and would then synthesize that data into a graphical design and then render an image for a human to work with. A key point about this was that the data came from the application in importance order, and then my system was able to try and take advantage of that importance order in terms of generating the image for the human to look at. Here is the key page out of the dissertation that describes how I took Bertin's theoretical framework and turned it into a program to automatically design graphical presentations. It was a language approach. You can see that very, very clearly here at the top, where I talk about the horizontal position language. So the figure above is a bunch of marks positioned on an axis. And then here, what I describe is how the relation is the relation between price, currency, and car is encoded by the position of the marks against the axis. And then what I did is I formalized this into a logic to describe the encoding against the axis of the position of the marks using a horizontal position encoding. And so it was this formal connection between the data and the visual that was based upon Jacques' framework. Now, as I said before, so what I needed was to be able to understand and then honor the importance ordering. And I built off of some work from Bell Labs by Cleveland and McGill, who had done a bunch of work with quantitative data and empirical studies. And they found that if you used position, it was the most accurate way of conveying quantitative data. Then you had slightly less accurate in terms of understanding was length, angle, slope, area, volume, and then at the bottom was color and density. So this was very, very useful for me, and I extended it to also encode the data as well. And so what I did is I added not just quantitative, which was based upon the Cleveland and McGill work, but ordinal and nominal. And what this figure shows is that there was also, based on Bertin, texture, connection, containment, and shape. And as you moved from quantitative, ordinal to nominal, those particular ones, not working for quantitative, would work well for ordinal and nominal. So the only other thing I needed was the ability to combine the individual parts together, just like you combine words into sentences. And I formalized 3 operators in an algebra to be able to do this combination together. And so the operators were single axis composition, where if the axes encode the same information the same way, you can combine them together. Double axis is both axes did that. And then mark composition, if the marks encoded the same information in the same domain, you could combine them together. Now, I have a video here of my actual system that I built.
Now I'll show you how apps search for design to present the class schedule information. Notice that the default search order will not be used for the prerequisite relation, because there is a rule that states that networks are good presentations for a relation from a domain set to itself, in this case, classes to classes. Note that apt is using the default search order for the scheduling function. When selections have been made for both relations, apt considers the composition operators: mark composition, double axis, single axis. Compositions fail until a vertical axis is used to encode the scheduling function. Once the design is completed, we can look at the presentations. Here is the presentation for the prerequisite relation. The nodes encode computer science classes, and links encode prerequisite relationships between the classes. For example, databases is a prerequisite for advanced databases. The scheduling function is encoded by the position of points on a vertical axis. The composition is based on the fact that these points encode the same information as the nodes in the prerequisite network. The resulting composition is the mark composition shown here. Notice how easy it is to see that advanced databases is scheduled before its prerequisite. This would be harder to determine from the two separate presentations.
So, after I finished my dissertation, I interviewed all over the country, and I ended up, surprisingly, just down the road at the Xerox Palo Alto Research Center. And one of the things that, so PARC, as it's commonly called, is a very famous place. It was the place that did a lot of the fundamental work on the personal computer. And when I showed up there, one of the reasons I went there was because of this man here. This is Dr. Stuart Card, who's now retired and actually spending part of his retirement at Stanford. But when he arrived at PARC years before I was there, he was interacted with the folks from Engelbart's team, including and did the basic usability studies on the mouse as a pointing device. And this picture here is a picture of the original Engelbart mouse, which the folks at PARC greatly improved from a physical point of view. Stu, who's a cognitive psychologist from CMU, was very interested in using visual techniques to help people work with data, and had purchased a couple of early Silicon Graphics supercomputers. And we did a bunch of work together. All at Park, I was there for 18 years. The core of it were probably the two most notable visualization techniques we developed using the Silicon Graphics supercomputers was on the left here is called the cone tree for looking at hierarchical information. On the right, called the perspective wall, which is a focus and context technique for being able to both see the detail and see the context at the same time. The perspective wall, in particular, I was able to use the linguistic approach that I'm talking about today as part of the theory for what to put on that wall. But I absolutely don't have time today in this short lecture to talk about the 18 years of work, except for to just skip forward to 1999, where Stu and I myself with Professor Ben Schneiderman wrote a collected readings book called The Readings in Information Visualization, Using Vision to Think, which is still a book that I recommend today as a good background for basic theory on how to do visualization. In particular, in chapter 1 of that book, we developed a basic reference model for describing how to do visual interactions. And the reason I show this figure to you is because you can see it's expanded greatly from my dissertation work. And I'm going to take you through this just briefly here so that you can understand how it works. On the left-hand side is the raw data that you might be trying to understand. And on the right-hand side is the human and the task they're trying to accomplish. Right in the middle of this figure is the mapping from data tables to visual structures. Now, the core of that theory is Bertin's theory about essentially the language approach for encoding data in tables. And so this is where the theory from Bertin, the language approach I'm talking about today, is exactly involved in this mapping, the visual mapping. To the left here is a part of the larger effort, which is data transformations of transforming the raw data into the data table. And on the right-hand side, back up. On the right-hand side, which is should have a red rectangle around. Oh, I see. Our slides got out of order here. Let me skip forward. Is the view transformations like the ones used in the perspective wall and in the cone tree. And then, so this is the basic reference model. And as you can see, every step of this basic pipeline, and that's how people in the academic community refer to this now, every step in this pipeline is under control of the human using various interaction techniques for being able to work with your data. And the other thing that in this book that introduced, which I had skipped over really quickly, but let me go back to it, is we also had a basic description after studying lots of people doing analytical work, which we call the knowledge crystallization cycle. And that brings me really quickly to Tableau, which is, I want to show you the modern version, the Tableau way of drawing that process for people working with data that was originally developed in that book, which is at the top here, there's some task that involves data that a human would want to use data to help with it. And I believe it's every task data can help with. And the first thing you need to do, going around the outside of this, is get the data, choose a visual mapping, view the data, because we have powerful visual systems, develop an insight, and act upon it. And so this is what Tableau is trying to help people do, is this complex backtracking process using a visual system. And which brings me then to Tableau. And in particular, these are the pictures of the three founders at Tableau. From left to right is Christian Chabot, Chris Stolte, and Pat Hanrahan. Pat is professor at Stanford, who I got to know because he spent some time at Park. Chris Stolte was his student, who I got to know because of Pat, and then I got to know Christian Chabot from both of them. But in particular, Chris and Pat had a breakthrough of technology of combining together computer graphics databases and human-computer interaction. And the core of that was an algebra building on top of my work and building on the top of Bertin's fundamental language approach called VizQL that specifies the relationship between queries and a view and builds, it allows for a highly interactive interface for working with data. And so you have the algebra, which is then used to generate a query, which goes to a data interpreter, then a visual interpreter, and finally a view. And that results in a very interactive process for working with data. Now, at the beginning of the talk, I promised for the people that know about Tableau is to lift up the covers a little bit and show you features that are based directly upon the language approach that Bertin developed. And in particular, those features involve the use of Show Me, which is a technique for recommending particular views, and it also uses that's on the right-hand side here, and on the left-hand side is automatic mark properties. Both of these are rules for automatically rules for helping people stay in the flow of their visual analysis. And I'm going to demo these in just a second for you. Now, in particular, part of what Show Me did was it took advantage of the understanding of things like these selection rules, in particular the columns values for them, and also the encoding properties, and it combined those together. And here is an actual table that describes the basic rules that Show Me uses for encoding data values. And so, in particular, Show Me will encode these seven, or no, will recommend these 7 different view types: text table, horizontal bar, stacked bar, line, scatter, Gantt, and map, using the rules. The default is to always recommend a text table if there's not a better view, and then the rank here tells you what the ranks are of the better view. So these are in order here. If you have a quantitative value, so this is building directly off of Bertin's work involving ordinal and quantitative values, a horizontal bar view will be recommended. And then if you have 2 quantitative values with a categorical stacked bar, and onward and downward, if you have a date view, then a line chart's useful. 2 to 4 quantitative values gets you a scatter as a recommendation. Gantt is pretty technical, but then if you have a geographic value, a map will be recognized for you. So now I promised a demo, and I have a particular data set I'd like to introduce for the demo, and that introduction goes like this. What happens when you have one of these and it meets one of these? If you're very, very lucky, you get one of these. This is, of course, the miracle on the Hudson when Captain Sully, who hit a flock of birds, was able to do a successful emergency landing on the Hudson, and everyone on board survived the flight. This has been my usual way of introducing this particular data set until just last year, when I was flying down to Texas from Seattle to visit some Tableau customers, and I was taking off on an American Airways plane from the Seattle airport, and just after we lifted up off the runway, the pilot came on board. He said, we actually hit a bird as we were taking off. I had no idea. We didn't feel anything. But the pilot said, the bird hit the front of our plane and took out our forward-facing radar, and I don't want to fly down to Texas without the radar, and so we're going to circle around and land here. And since there were other birds in the vicinity, I'm going to wait for the emergency vehicles to get on the runway before we land. So we circled around for a while and then finally landed. It was very comforting to be rolling down the runway. And then when I got off the jetway, this is what I saw in the plane that I had been on. And as you can see, there was a dent in the nose, which is actually a cover over the radar. But nevertheless, I felt quite relieved to have landed. Now, my goal here is to put you into an analytical frame of mind, because I want you to feel what it's like to do visual analytics. And what we discovered after the miracle in the Hudson, somebody at Tableau found that the FAA had a wildlife strike mitigation working group who's collecting reports from pilots about wildlife strikes. And this is a typical data that you might want to do analytical work on. On the left here, you see a date column. Then there are string columns like airport and state, and quantitative columns like height and speed. Every row here is a report from a pilot. And so this is the data set that I would like to demo and show you a little bit about the Show Me feature. So I'm switching over to the live demo now. And it should come up in a moment. Okay. I'm not sure why the demo is not kicking in here. There we go. I think we're live now, or almost live. Good. Okay. So here's the data set on the right that I was showing you before. On the top here are a bunch of string columns, like information about aircraft, airport, the amount of damage here, flight date, and then if we had more time, we could go all the way down. You can see there's information about the species, and then there's a bunch of quantitative values, cost, feet above ground, and number of strikes. The basic user experience in Tableau is simple drag and drop, where I can drag out the number of strikes, and you can see here a bar chart that shows that in this particular data set, there's 245,000 reports to the FAA from pilots about the number of strikes. And for this particular question, is it safe to fly, the amount of damage column is probably a good place to start. And so I'll drag and drop that on the row shelf. And you can see we broke the bar chart into a number of bars. And the top one is null. Null means that the pilot didn't enter anything into the field amount of damage. 51,000 reports, probably no damage at all. I can also take the amount of damage and drop it on the color shelf and color encode the values here. And here you can see none, 170,000 reports from the pilot, 12,000 minor, medium, substantial, and then there's a small number of destroyed here, 162 destroyed. So you can already start to see that it's probably fairly safe to fly. But one thing that happens when you're doing visual analysis is that once you're starting to see your data, other questions can come to mind. For example, here's a cost field. What's the relationship between number of strikes and cost? Well, you can do that in Tableau, answer that question very easily by dropping the cost field and getting 2 columns here. And what you're seeing is essentially inverse correlation, where the number of strikes is dropping, but the cost is going up. Not surprising the cost is going up. This is damage, after all, here. But what was somewhat surprising the first time I did this was the size of the orange bar. Here it shows $860 million worth of damage, and thus it's like makes a lot of sense why the FAA has a wildlife strike mitigation working group. But if you think about this, maybe I haven't completely covered whether it's safe to fly because we're only looking at counts. There may be other reasons why, like for example, in different locations, it might be more dangerous to fly. Like Seattle is a bird migratory zone. And so I can go off and explore that as well at Tableau by, I'm going to go to a new sheet and I can grab origin state and drop it on the detailed shelf, and I can get a map. And then in particular, so here I'm starting to work on a map. I can open the Show Me feature, and you'll see that Show Me is recommending here a symbol map. If I had originally dropped the number of strikes on the color shelf, it would still that would have been a filled map. But Show Me is saying no, a symbol map is a better way to encode these values. So this is basically the rule from Bertin. And if I click on Show Me here, then I get a symbol map where I can very clearly see the quantitative values encoded in size and understand their relationships of them against each other. So that's a very, very brief example of the use of Tableau for exploring data and also using Bertin's theory of language. So this brings me almost to the end of my talk, at least brings me to the current day. And I am now, one of my responsibilities is to help Tableau innovate, and as part of that, Tableau has an authentic industrial research group called Tableau Research. Here are the members of the research team, with Maureen Stone in the upper right-hand corner. She's the leader of Tableau Research. And one of the things that we're doing as a research group is trying to help all phases of the process of working with data. And so I brought up the reference model, the pipeline from the academic community that was built in my thesis. And down below is our current way of describing all the different tasks that people have to accomplish from data to people in working with data, from connecting to the data all the way on the right-hand side to telling stories with data. And so I thought I would pluck out one of the research topics that we're working on in Tableau Research to give you a sense of how we're still building off of the fundamental language approach for working with data. And that's a research project that we've been publishing on that's using natural language techniques to support visual analysis. And here's a picture of one of the papers it's a prototype system called Avisa, which is trying to help people who may not be highly skilled at doing visual analytics to get the value out of their graphical encodings of data. And so in particular, we're using knowledge about pragmatics to be able to help have a natural conversation with the data value. And so here are two parts from the key figures in that paper. At the top is from the entire state, a person types in, "Show me the large earthquakes near California," and the system responds with a highlighting of those particular earthquakes and provides some widgets below that you can use to possibly modify what you mean by large earthquakes and how near California you want to have. And then, as humans are naturally inclined to do, they just give you a sentence fragment. How about near Texas? And the pragmatics module in the Avisa prototype realizes that we're talking about earthquakes, we're talking about near, and so it just updates the view automatically to show earthquakes near Texas, and in fact large earthquakes near Texas. So as you can see, this is also a language approach that's proceeding forward, and we believe there's lots of other innovation that we can do to continue building on top of Bertin's work. So thank you very much. Now we've moved into the Q&A part of this talk, and I really appreciate your attention.
Well, Jacques, thank you so much for that excellent presentation. So we'll get started with today's Q&A session, and I want to thank the audience for their participation. We've had a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. And during this Q&A session, I'll leave up this screen with contact information for Jacques, if you'd like to contact him following today's webinar. So let's get started. Jacques, Bertin's book, obviously extremely foundational for you. Were there other people at that time or later that were also equally struck by his work?
So yes, I wanted to acknowledge there's another book that is that's also very worth reading that came later. It was written by Lee Wilkinson. It's called The Grammar of Graphics. Lee is a very skilled statistician, so it brings in a thread that is very important, which is the statistics community is very, very experienced at doing analytic work, and in particular, Wilkinson's algebra is different than the one that I built off of Bertin, and then Tableau ended up using, but it's very related, and so I absolutely recommend that that people go look at the Wilkinson's Grammar of Graphics books, and then the other thing along those lines, there is a professor at the University of Washington, Jeff Hare, who's been building off of both of these theoretical frameworks and has a set of graduate students that are working way there. So if you're really academically inclined, you can also go look at Jeff Hare's work as well. But in other words, there's been some branching here, but there's a real line of work here that is on sort of the language approach that the academics are pursuing in one way or another. Thanks for the question.
Well, Jacques, thank you for that answer. You know, when you were talking about the diagrams, and I think the audience understands that these were called the Bertin's permutation matrices, one of the things that struck us was how specific they were in the number of characteristics that you could use for each type. And the audience is wondering, how did he come up with those very specific numbers, especially so far back before computers were available? Were there thousands and thousands of human tests, or how did he do that?
No. So that's the interest. That's why I actually showed you the map of Bertin and that he had in his office. Bertin had an artist's eye and was also simultaneously deeply introspective about what actually worked. So his effort to do that was based upon his talent, I would say. It was only much later that we started to have the actual human studies to validate that he was correct in terms of his analysis. What a tremendous achievement on his part to do that. What's really interesting is that the studies that have come since then have shown that there are additional techniques that you can use to encode data that have pre-attentive properties like the 6 that Bertin identified. Only the 6 Bertin identified has this property that they can be combined simultaneously, and they're also the ones that our visual system is the most effective at. So he always obviously had to tease his way through other graphical properties to identify the key ones that are most useful.
Well, thank you for that clarification. Here's a very practical question. Obviously, the audience was very interested in the bird strike data, and glad you're safe. But can you tell us where the audience can find that data set so they can play with it themselves?
Yes, you can go to the FAA, and it's an access database. You can also email me. I'll send you it. Send you it as a Tableau extract. the interesting thing about the data is they actually have 4 tables in the Access database, and so you do have to do a little data preparation work to be able to combine it together. You have to union the tables together, and then there's a separate data dictionary for attaching values. At Tableau, we call this data stewardship, cleaning up the data. So I would be delighted to send you. I've been a data steward on that data set, and I'd be delighted to send it to anybody who wants it.
Well, Jacques, thanks. That would be fun to play with. Now, here's also a very practical question. You know, in this day of open source, with a lot of analytic shops using R and Python, this audience member says that they have both a Tableau license and access to Python's data visualization libraries. Can you give us some pros and cons about why we should be using Tableau instead of Python, or vice versa?
You know, so my answer is going to be, so yeah, this is an or question. I'm going to say and is my answer, which is to say you can use both of them together, and we are actually working on that directly. But already, Tableau supports connection both to R and to Python libraries. You can find the detailed information about that on our website. But the combination of the two together is, particularly if you are a person that can do R scripting or write Python programs, is a fabulous experience because the visual support of Tableau is directly tapping the power of your visual system, and then of course you can do more advanced analytics by writing those scripts or those programs. And we want, you know, there are some limitations in the connection to R that we're working on expanding, and we have been expanding it over time. But in general, anyone who has these sorts of skills or data science skills, Tableau is a really useful tool because it taps your basic human visual skills and provides a really rapid exploration environment for answering questions. And also you can use it for storytelling. So it's really an and. If you can use R or the Python libraries, you should do that, and you can also use Tableau to support you.
Well, Jacques, thank you for that great answer. Now here's a very specific question also, and I expect that there are a lot of members that are using Census Bureau data. This member quotes specifically the American Community Survey data that I think you may be familiar with. But the question is, how do you effectively display margin of error on charts and maps that would help their audience understand the specificity of what they're talking about?
So I've not personally done any analytics with that data. And of course, the challenge about maps in particular is the map is providing context for the data that you're showing on it. But if you think about it from the Bertin point of view, you're using up some of the graphical vocabulary that you have for just providing that context. So it is actually very difficult to add in things like margin, showing the margin of error. There are people who have done various things along those lines, but of course it requires a sophisticated reading. Notice that I'm using the language approach language there again. If you have marks on a map and then you're also using graphical properties to show margin of error, the person who's looking at that view has to have some sophistication to be able to understand how the margin of error is encoded on the map. It is certainly possible to do, and certainly for people who are working with that sort of data on maps all the time, they can learn how to do that. I would argue that the other way to do that, also implicit in this talk, is to, once you have the basic context of looking at your data on the map, if you really want to go look at margin of error, you might switch to a different view type, like, for example, bar view, or if you're dealing with temporal data, line view, where it's easier to actually see the margin of error encoded because you no longer are using up part of your graphical vocabulary. Again, see the language approach in my answer. I don't normally stick that in, but for this talk it makes sense. That allows you to more rapidly see the margin of error. Great question.
Yeah, Jacques, and great answer too. Thank you very much. You know, this audience member is asking that since they use the Tableau display as a dashboard, can they stream live data in there, or how rapidly can the Tableau display accommodate updating streaming data?
So from the very earliest days at Tableau, you know, we've been around. I've been at Tableau for about 14 years. There was you could refresh your data. We have an ability to live connect to data sources, but of course, it takes some time to do the data computation and build the graphical view, which we're making faster all the time. But we haven't actually focused directly on essentially streaming data. We are working on the pipeline to make it faster, to be able to do all the computations we need to do to build the graphical views. We actually find when we talk to our customer base that live streaming is an absolute need of some of our customers, but most of them are perfectly willing to have a slight lag from actual live. The applications that really need instant update are a couple of examples would be if you're doing analysis of the live analysis of the stock market fluctuations, or intrusion detection, or anything involving real time. And in those cases, frankly, recommend that you build do some custom programming to actually be able to mitigate whatever delays you can in those particular applications. But I would describe Tableau as near real time, which is to say you can get an update anytime you want, and you can actually also often people don't need an instant update. It's like the way to think about this is it takes some time for a human to do their analytical work, and if the view is updating right in front of them in real time, unless the work is specifically about that, like watching a radar of a plane landing or something, it's distracting. And so for humans, the reality of it is that most tasks do not require live update.
Well, Jacques, thanks. And I'm sorry we're out of time. I really would be interested to hear more about the research directions, especially you talked about Evisa, and I'm sure there's some other fascinating stuff coming down. But thanks. Great answer to some very good questions. And for those of you that asked questions that weren't answered today, we'll be sending all the unanswered questions to Jacques and the Tableau team so they can follow up with you after today's webinar. Well, I have just a few quick announcements. If you'd please mark your calendar for July 27th, that's Thursday of this week. That's our next DSC webinar, which will be the Art of Self-Service Data Analytics, and that's going to be sponsored by Alteryx. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the homepage of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close, and I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Tableau for their sponsorship and our speaker today, Jacque Mckinley, for his insight into today's topic. You know, my name is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on July 27th. Have a great day.